Next, we're going to do some examples using permutations. Now, we could use the fundamental counting principle for all of these permutation problems, but there's a shorter way of doing it using the permutation formula, which allows you to determine the number of permutations or arrangements given specific parameters. The notation NPR means the number of possible permutations of n things taken r at a time, and the algebraic notation is NPR equals n factorial divided by n minus r factorial. Now, the way we read NPR is there's a couple different ways of saying it. We could say permutation of n comma r. We could say permutation of n choose r. There's also a couple different ways of writing it. Some books will write it P with an N and an R that way. The book that we're using has the N in the front and the P and the R in the back. And there's also another way some books will write it like that. It doesn't really matter, but in case you see it in your calculator written slightly different, or in another book, you might see it slightly different, which is all okay. So I'm going to go through the first example, and I'm going to do it two different ways. I'm going to show you how to use the formula, and I'm also going to show you how to use the fundamental counting principle. So, for example, suppose there are 8 swimmers in the final race at the swim meet. First place gets gold medal, second place gets silver, and third place gets bronze. How many different ways could the swimmers medal? So we're talking about just the medal placers, so first, second, and third place. So if I'm using the fundamental counting principle, I would note that there was 3 spots. There are 8 swimmers, so we have 8 swimmers times 7 swimmers times 6 swimmers. And then we take 8 times 7 times 6. And that's going to get me 336 different ways that the 8 swimmers could actually medal first, second, and third place. Now I'm going to show you how to use the formula. Now, at times this formula might seem like it's more difficult than the fundamental counting principle, but when your problems get harder and bigger, the formula is going to be really nice. So I'm going to have to identify what's n and what's r. N is the number of things in our group. So how many total swimmers we got? We got 8 swimmers. And how many are we choosing? We're only choosing the first 3 places. Does the order matter? Yes, it does. The order definitely does matter, so it definitely is a permutation. So when I plug it in my permutation formula, I'm going to write 8 and 3, so 8 choose 3. And on the numerator, I have 8 factorial. On the denominator, I have 8 minus 3 factorial. And 8 minus 3 factorial is 5 factorial. And we just practiced dividing factorials. So we have 8 times 7 times 6 times 5 factorial over 5 factorial. So the 5 factorials divide out, and you have 8 times 7 times 6, which is still 336. Now I'm going to show you one more way to get it in the calculator. Some calculators, not all calculators, but some calculators may be able to go ahead and type 8 choose 3 right in the calculator without actually having to do all the work. Now, when you show this to me on the test, you either need to show it to me on the fundamental counting principle way or the using the formula way. One of the 2 ways you need to show on your work. So when I do this, if I want to check my work, on my particular calculator, I don't have the P and R button on the face of my calculator, but under the probability, I have NPR. Now, because the n's in front on my particular calculator, I first want to type in the 8, then use my probability button. That's the same button where I found my factorial. And then I'm going to choose the first choice, which is NPR for the probability. And then I type 3, and I hit enter, and I'm still going to get 336. So yes, you have to show your work, but you can also check in your calculator and just type it in if your calculator has an NPR. Now, if you have another calculator that looks something more like this, where you might have it on your computer or something, you can do 8 factorial with that N button right here. But this particular calculator, even under all of the other choices, it doesn't actually have an NPR. And a lot of them, you're not going to have an NPR. So you're going to need to know how to do it using the formula or the fundamental counting principle. So for our next example, we have a corporation has 7 members on its board of directors. In how many different ways can it elect a president, a vice president, a secretary, and a treasurer? Does the order matter here of the vice president, the secretary, and the treasurer? Sure, the order matters. And the reason the order matters is because the president has different duties than the vice president, which has different duties than the secretary and the treasurer. So the order in which we put them in matters. If I assign the first slot to be the president slot, the second slot to be the vice president, the third slot to be the secretary, and then the fourth slot to be the treasurer, and it doesn't really actually matter which one I put first, second, third, or fourth. But if I assign one of the spots to be president and one of the spots to be treasurer and so forth, then order is going to matter because everyone has different duties, right? Now, in my corporation, I have 7 members on the board. So how many different ways could we have a president? Well, there's 7 different ways if we choose the president first. Now, again, it doesn't really matter who you choose first, but you have 7 total choices. After you make the first choice of one of the categories, then you only have 6 for the next one, and then you only have 5 for the next one, and then you only have 4 for the next one. And so when you multiply that out, 7 times 6 times 5 times 4, that gets us 840. This again is using the fundamental counting principle. Let's go back and do the same problem with the formula. So we're choosing our 4 different people or positions from 7. So 7 choose 4. So I have a permutation of 7 choose 4. So we have 7 factorial on the numerator, 7 minus 4 factorial on the denominator, which gets us 7 times 6 times 5 times 4. In the denominator we have 3 factorial. So that tells me in the denominator, because I have 3 factorial, I want to stop at 3. That means that the 3 factorial divides out, and I have 7 times 6 times 5 times 4 again, which gets me the same answer of 840. Another way you could use your calculator is you could use your factorial button. We could have 7 factorial divided by 3 factorial. And that's still going to get you 840. Now let's say you had another type of calculator. So let's say you had a different type of calculator that didn't have the NPR or nChooseR function on it. We do have a factorial button. Maybe let's say you have a factorial button. You could just do n factorial, which is 7 factorial, divided by 3 factorial. Then make sure you hit enter, and then it actually computes it, and it's still 840. So there's a couple different ways of getting your answers there. Going on to our last example, we have, suppose you're asked to list in order of preference the 3 best movies you've seen this year. If you saw 20 movies during the year, in how many different ways could you choose the best 3? If you're doing the fundamental counting principle, you have your first best, the second best, and then the third best. So that gives us 20 different options for the first best movie out of the 20 that you happen to see. Because you've already assigned one to be the best, you have only 19 left, and then you only have 18 left for the last spot. So 20 times 19 times 18 using the fundamental counting principle gets us 6,840 different ways that you could assign the top 3 movies of the year, in your opinion. Next way we could do it is we could do nChooseR. We have 20 total movies. We're picking only the top 3. So the permutation, 20 choose 3. We have 20 factorial over 20 minus 3 factorial, which is 20 factorial over 17 factorial. If you wanted to do that in your calculator, you could just do 20 factorial divided by 17 factorial and hit enter, and you'd still get 6,840. If you don't have a factorial button on your calculator, you would do 20 times 19 times 18 times 17 factorial over 17 factorial. The two 17 factorials would divide out, and you'd type 20 times 19 times 18 in your calculator, and you'd still get 6,840. And this concludes our lesson on permutations.